Interference of waves. The phenomena of the light which undergoes refraction and reflection can be explained by the two theories of light. They are the corpuscular and the wave theory of light. But some of the other phenomena, such as interference and diffraction, can only be explained by the wave theory of light. We know that two or more wave motions travel in space at the same time. Sometimes these two wave motions combine and some physical effects take place. Interference is one such physical effect. When two or more waves cross each other in the same medium, they both interfere and an accident takes place. This accident is known as the interference of waves. Interference is the combined effects of the disturbance caused by each individual wave at the same place at the same time. This effect can be understood from the principle of superposition of waves. Principle of superposition of waves. To understand this concept of the superposition, let's understand some of the examples. When we drop a pin in a tank, we see some circular waves. When another pin is dropped, we see some more waves. These waves travel in the same tank, and at one time or another, they superimpose on each other. The resultant wave would have an amplitude which is the sum of the displacement due to the individual waves. The principle of superposition of waves states that when two or more waves traveling through the same medium simultaneously, the resultant displacement at any point is the vector sum of the displacement due to the individual waves. In our case, the pin is dropped in a ripple tank with two pins. If y1 is the displacement caused at a point due to the first source, and y2 is the displacement caused by the second source, then the overall displacement r at the point of interference would be given by r equals y1 plus y2. When both sources have the same amplitude, then y1 and y2 would be equal to y. When y1 is due the crest or trough, and y2 is also due a crest or trough, the resultant would be the maximum. And when y1 is due to a crest and y2 is due to a trough, or vice versa, the displacement would be minimum. When maximum displacement takes place, it's called constructive superposition, and when minimum displacement takes place, it's called the destructive superposition. In constructive displacement, a maximum displacement curve is produced. Thus, when constructive displacement occurs, the phase difference between the waves would be 0, or a multiple of 2. When minimum displacement occurs, waves superimpose destructively. The phase difference of the waves would be an odd integer multiple. Interference of waves. When superposition of waves occur, they can be destructive or constructive. This physical effort, observed as a result of the superposition of waves, is called interference. The physical effect of the superposition of waves from the source vibrating with the same frequency and amplitude is called the interference of waves. The physical effect is in the form of vibrations in the amplitude of the resultant wave in a given portion of the medium. Interference is a special case of superposition of waves, which originate from different sources but have the same amplitude and same frequency.